Okay, surgical diathermy. Surgical diathermy means you will be following all the surgical procedure while doing this diathermy process. But before this type, diathermy types, ultrasonic type இருந்தாலும் சரி, short wave, microwave, இதிலெல்லாம் பார்த்தீங்கன்னா you will not be doing any surgical. Okay, surgical procedure will not be followed in all this type. uh, uh, just you will be placing the electrode above the part, above the surface of the skin. But here you are going to use this treatment in the surgical procedure. That means here you will be uh, using this diathermy process for uh, bleeding, stop the bleeding as well as cutting process in the tissue. Okay. So electrosurgical unit. So electrosurgical unit la patina the electronic device which will be assisting the surgical procedure by providing cutting and hemostasis, which will be stopping the bleed of blood. Okay, is said to be electrosurgical unit. See here, this is the complete setup of your surgical diathermy. So treatment will be taken internally or internally to the internal organs. So the coagulation and cutting, these are the two process will be done by your surgical diathermy. So tissue cutting, coagulation means you will control the bleed. Okay, you will clot the blood. So both value, intensity value will be maintained. Based on the intensity value, you will be giving the uh, signal to the or heating effect to the affected area of the body. Okay, or affected parts or organs of the body. So the electrosurgical unit consists of two electrodes, one being called the active electrode and another one called as passive electrode. So passive electrode, another name dispersive electrode. So this passive electrode will be placed on the patient plate. Okay. So the active electrode has a small cross-sectional area, whereas the passive electrode has a larger surface area. A high frequency electrical current will be passed through this electrode. So due to far smaller cross-sectional area, the current density at the active electrode is far greater than that the passive electrode. So the current density value will be high in active electrode rather than your passive electrode because of its small area, cross-sectional area. Okay. As a result of this, the tissue underneath the active electrode is heated up to distract destruction. Okay. So the active electrode underneath part will be heated, will get heat. Okay, heating effect. So these are the word going to be used in the surgical diathermy. First, electrotomy. So electrotomy is not nothing but process of cutting the tissue through the application of high frequency current. So on applying the current to the electrodes, that is active and passive electrode, you will be doing the process of cutting. Cutting means cutting the tissue. Okay. Fulguration. Fulguration இது ஒரு process தான் which will be destroying the unwanted tissue. Okay. So unwanted tissue will be removed or destroyed by using this process. That process will be called as fulguration. Okay. So on cutting that tissue, which will not be affect the remaining tissue. Okay, so the particularly affected tissue alone will be removed off from the body. Then coagulation. Coagulation means on applying the electric field to the plates. So electric field nave high electric field தான் apply பண்ண போறீங்க. High signal nave high frequency இருக்குன்னு தான் அர்த்தம். Okay. So high frequency signal, high signal, everything same meaning. So on applying that electrical signal to the tissue, it will be coagulating. That means it will make the blood clot in that particular area. Okay, the blood movement will be stopped. That means it will make the liquid form into semi-solid. Okay, then desiccation. In In desiccation process, needle point electrodes are stuck into the tissue and then kept steady. Depending upon the intensity and duration of the current, a high local increase in heat will be obtained. So, desiccation process, you'll be using needle point electrode. Needle point in electrode is nothing but injection like. Okay, it will be inserted or penetrated into your body tissue. So on the body tissue la the needle அப்படியே constant you will be keeping. So you will be varying the intensity value and the timing value in the machine, diathermy machine. So based on the setup, that is intensity value and duration, you will be applying the heat to the tissue where you are keeping the needle point electrode. Okay. So you'll be increasing the electrode, decreasing, increasing, decreasing. So based on our needs, you will be doing the setup in the machine. Okay, that is desiccation method. This is just for like making stimulating the tissue. Okay, that's why you'll be using desiccation process. This is the various types of electrosurgical technique which will be employed in a practice: electrotomy, pulverization, coagulation, desiccation. Okay, these are the four techniques shown in diagram. இதெல்லாம் பார்த்தீங்கன்னா கொஞ்சம் ரொம்ப டெப்தா போகல, but you are going to penetrate the needle only in the desiccation process. So the concurrent use of continuous radio frequency current for cutting and a burst wave radio frequency for coagulation is called hemostasis mode. Okay, so continuous radio frequency signal will be provided for cutting process. So the burst wave radio frequency will be provided for coagulation process. So this process of providing different types of signal will be called as hemostasis mode. In the figure 27.3, this one, this is nothing but types of waveform generated during the surgical diathermy in the machine. So first one, cut waveform generated by electronic tube circuit showing RF modulated by 100 hertz. So this is 100 hertz waveform during cutting process. Okay. செகண்ட் பார்த்தீங்கன்னா இதுவும் கட்டிங் ப்ராசஸில் பண்ண ஜென்ரேட் ஆன வேவ் ஃபார்ம் தான். பட் இது வந்து சாலிட் ஸ்டேட் டயத்தமி மெஷினால் ஜென்ரேட் பண்ணது. அதனால தான் யூ வில் பி கெட்டிங் த கான்ஸ்டன்ட் அவுட்புட். ஓகே, பட் இது வந்து எலக்ட்ரானிக் டியூப் ஜென்ரேட்டட் வேவ் ஃபார்ம். இது வந்து சாலிட் ஸ்டேட் டயத்தமி மெஷின் ஜென்ரேட் பண்ண வேவ் ஃபார்ம். தட்ஸ் வை இட்ஸ் லுக்கிங் கான்ஸ்டன்ட் அட் ஆல் டைம். So the cutting current usually result in bleeding at the site of incision, whereas the surgeon would require bloodless cutting. So if you cut a part, இந்த சதையை ரிமூவ் பண்ணுவாங்க இல்லையா, கட்டியை ரிமூவ் பண்ணுறாங்க, சில இடத்துல தேவையில்லாத டிஷ்யூஸ் எல்லாத்தையும் ரிமூவ் பண்ண, டெட் செல்ஸ் டெட் செல்ஸ் எல்லாம் ரிமூவ் பண்ணுவாங்க இல்லையா? ஸோ அந்த மாதிரி இதில் யூ வில் பி யூசிங் திஸ் ப்ராசஸ். அப்போ என்ன ஆகும், ரிமூவ் பண்ணுறப்ப யூ வில் பி லாஸிங் பிளட். ஓகே, ப்ளீடிங் ஆக சான்ஸ் இருக்கு. ஸோ அந்த மாதிரி இல்லாமல் பிளட்லெஸ் கட்டிங் தான் உன்னோட டாக்டர் ஆர் சர்ஜியன் வில் ப்ரிஃபர். ஓகே, தட் இஸ் given here. The machine achieve this by combining the two waveform. So இந்த மாதிரி bloodless cutting வேணும்னா you have to, the machine have to combine the two waveform. Okay. The frequency of this blended waveform is generally the same as that used for cutting current. So இதை blend பண்றப்ப இந்த ரெண்டு waveformையும் blend பண்றப்ப the same effect, heating effect has to be produced during the cutting process. Okay. ஸோ இந்த ரெண்டு வேவ்ஃபார்மையும் blend பண்ண போறாங்க. blend பண்ணது தான் இது. ஓகே, blended waveform generated in a solid state diathermy machine தான் third waveform. Okay, first வந்து coagulation waveform which will be generated due to the spark gap generator. இது வந்து solid state diathermy message generate பண்ண coagulation waveform. ஸோ இந்த ரெண்டு waveformையும் mingle பண்ணி, இல்லை cutting processல பார்த்தீங்கன்னா இந்த ரெண்டு waveformையும் mingle பண்ணி தான் you will be giving for avoiding the bleeding in the tissue. Okay. So the use of high frequency current offers a number of important advantages. So here we are using high frequency signal only. So using high frequency signal will provide some advantages that are the separation of tissue by electric current always takes place immediately in front of the cutting edge and is not caused by it. So by using high frequency signal, you may give treatment only for the affected area. The remaining tissues will not be damaged. Okay, uh, it will be separated from the affected area. Okay, by providing the high frequency signal, it may isolate the other tissue parts. Okay, that's the first advantage. Then electric cutting therefore does not require any application of force. ஸோ இந்த ஃப்ரீக்வன்சி சிக்னல் யூஸ் பண்ணுறதுனால கட்டிங் ப்ராசஸ் நடக்கிறப்ப எனி ஃபோர்ஸஸ் will not be needed during the cutting process. Okay, instead it facilitates elegant and effortless surgery. ஸோ இதனால என்ன ஆகும், you can achieve the elegant and effortless surgery without any cost, that means damage or more effort. You can do the surgery simply. Okay, the electrode virtually melts through the tissue instantaneously and seals capillary and other vessels, thus preventing contamination by bacteria. What is that? So on applying the high frequency signal you may avoid the contamination, okay, by bacteria. ஸோ எனி இன்ஃபெக்ஷன் ஆகாமல் இருக்கிறதுக்கு ஆகாது. ஓகே, இட் வில் நாட் பி அஃபெக்டட் பை எனி இன்ஃபெக்ஷன்ஸ். ஓகே, then biological tissue can only be cut when the voltage between the cutting electrode and the tissue to be cut is high enough to produce electric arc between the cutting electrode and the tissue. So the cutting process will be done while you are applying the voltage to the electrode. You have to create the electric arc in the tissue. Okay, then only you will be getting time acha. Okay, இந்த ரெண்டு ஸ்லைடை மட்டும் சொல்லிடுறேனேடா, நாளைக்கு இந்த coagulation mode போயிடுறேன். ஒரு 2 minutes I will be teaching very fast. So if the voltage is less than 200 voltage, then the electric arc cannot be triggered and the tissue cannot be cut. So 200 voltage கம்மியா இருந்ததுன்னா it cannot be triggered. So the voltage suitable cutting range will be between 200 to 500. Okay. So if the voltage increases above 500 voltage, the electric arc will become intense. That is, it will be making the tissue to carbonize, so that your electrode may gets to damage. Okay, when you are using the voltage value more than 500 voltage. Then a visible arc form when the electric field strength exceeds 1 kilovolt per millimeter in the gap and disappears when the field strength drops below a certain threshold level. So you have to maintain the threshold value to form the visible arcs in the tissue. Okay. So biological tissues are coagulated by thermal means if the requisite temperature is maintained at around 700 Celsius. Okay. So coagulation, that is clotting of blood in the biological tissue, will be maintained only in the 700 degrees Celsius. 700 degrees Celsius is nothing but temperature.